Okay, AP friends, here's your challenge. First is the circle. Can you find the area of a circle using calculus? All right, so we need equations, and we need to be able to find the integral to use area. So let's set up our circle. Let's put our center at 0, 0, so it doesn't have to be a shifted one. And the circle just looks just like this, as you know. And the most important part is this distance here, which we call r. All right, you know the formula for the area of a circle. We just need to get there using calculus. Now, if you remember the actual equation of a circle, if it's centered at 0, 0, it's just x squared plus y squared equals the radius squared. So now if we're going to set up integrals, we're going to need to split this into two functions and do a top minus bottom like we talked about in class. So I would suggest you take this top part in green. That would be a good top. And you're going to subtract the bottom. And the bottom here would be the second or the bottom semicircle here. Which means in order to take the integral, you're going to need equations. So we're going to need to take this formula that I have here and solve for y. So we can have the y top and the y bottom. All right, so if you solve for y, you should get y equals plus or minus the square root of r squared minus x squared. All right, so I think the top would be the plus and the bottom would be the minus. So now if you go back to your picture, look and see how we're going to set up that integral of top minus bottom. Notice when you do that as well, what are going to be the limits here? From what x value to what x value? Now, as you work with this one, you're going to need a very, very unusual and important integral formula. And it's the integral of what we say, here we go. How about a squared minus x squared dx? It's a special one that we don't know by memorization or by use substitution, so we have an integral formula sheet on the back of our book. We can use that. Or BC Calculus actually studies this one. But here's your formula. The integral of the square root of a squared minus x squared, and a squared is just a constant, is, how about x times the square root of a squared minus x squared plus a squared times the sine inverse, how strange, of x over a. And then because I didn't put any limits, normally this would be plus c, but of course you're going to be doing definite integrals with numbers or letters, so you will not have a plus c. You'll get an actual answer out in terms of a's and b's and c's and r's and so on and so forth. So just think about, here's your r up here, your r is going to be replaced by an a, or vice versa. Where you see an a, you're going to put an r. So use this formula down here, guys, because you're going to see this in your integral. You're going to wonder, how do I anti-derive that? Well, there you go. So that's how I would approach the circle. You've got your equation, you've got your top and your bottom, set up your integral. You know the area of a circle formula, so now get there. Good luck.